Okay, well, so yeah, thanks for inviting me, and I'm really excited to talk to you. So because just as it happens, we had a meeting 2 weeks ago where we talked about the fact that lots of the causal inference functionality in R, at least in the R universe, is scattered across all of these different packages, and it would be nice to kind of have a more joint, view, and maybe be a bit easier to interoperate with each other, which looks pretty much like what you're also trying to do. So maybe you can learn a lot from you. But you may also know that it's kind of hard to get this kind of initiative off the ground with like very different people with different ideas. So
Yeah.
yeah, so that's really interesting. We should definitely talk about that, how that's going and how that's working out for you. Would be really
Yeah, I
interesting.
think we can have a discussion today. And maybe I'll start by just introducing you, Johannes. So Johannes Textor is the creator of DAGitty. It's one of my personal favorite tools. And as many of you in the PyWhy community would know, we refer users to the DAGitty tool whenever they have questions about causal modeling and so on. And PyWhy also supports easy importing of DAGitty graphs into our ecosystem. So when we were starting this talk series, we thought one of the persons we should definitely invite is Johannes and learn from him as he has built the DAGitty user community. And also in general, if we have time, we can have a discussion on how these two communities, the R community and Python community, could work together and how we could build tools to make it much easier to
Yeah,
translate
that's
and
really
build.
interesting. Yeah, so I actually also think I will leave quite a bit of time in the end for discussing. So I just want to talk through a few things with you. Sorry, by the way, for the title. That's actually still messed up. This is not the same talk I get at the Science Institute. I just actually took the title slide and forgot to change the name, but the rest is actually different. So yeah, so I wanted to talk about actually three different things. So one is maybe just to give you a bit of history. And yeah, by the way, so first of all, I want to thank people who I worked with over the years on DAGitty. So Anku is actually here and has been working with me for the past 4 years on causal inference. Inge, also member of our group, she has been helping us with testing of causal models, and then many other people that I worked with over the years. So let me maybe just start to go back a long time. So DAGitty, the tool itself is really very much inspired by epidemiologists who were, yeah, I think maybe the first large community to really pick up on causal diagrams. So here you see a classic paper by two very famous epidemiologists, Sander Greeland and James Robbins, who wrote in 1999 already about how you could use causal diagrams for epidemiologic research. So this paper did gain some traction, but it took, I think, yeah, 7, 8, 9 years for people to start picking up this methodology. So first of all, it was more in this paper, for example, but then it started to appear in certain textbooks. So Sander Greeland, for example, is also the author of a major textbook in epidemiology. And so that methodology of causal diagrams found its way into these textbooks. And then at some point, people started to, yeah, because you can do in theory, you can do everything in causal diagrams using pen and paper. But there was quite early on a demand for software and really for programs that would support these kind of methods. So I just stumbled upon this whole topic by accident because I had a friend, Juliane, who is an epidemiologist, and she was in that community at the time. And just by chance we started talking about these DAGs. So I at the time I was a PhD student in theoretical computer science. I was really very much interested in algorithms. So just by chance, I stumbled on this community that was trying to implement causal inference methods. And the first thing I was really interested in was more the algorithmic part. So one of the first software packages that existed was this thing called a DAG program, also written by two people in Germany accidentally. And so this was an MS-DOS command line tool. And that was basically able to search for adjustment sets. This tool worked, right? So you could have a textual description of a causal diagram, you put it into this tool, and then it's actually basically computed a backdoor criterion to find adjustment sets. So listed all kinds of candidate covariate sets, and for each of them it would test the adjustment criterion. So that is in theory all fine, but in practice this really gets quite slow really fast, because you have to search through an exponential amount of possible backdoor sets. And then they literally listed all of the pathways between exposure and outcome, and that's also a very large number. So you had really a very, very poor runtime complexity that led to people really being unable to analyze diagrams that they had drawn by hand. So that's what actually caught my interest. So I had no knowledge of epidemiology or causal inference, but I really was interested in this algorithmic problem. And that was how DAGitty started. So I started to realize that there are more efficient algorithms, but actually there were also some open questions. So we started to write some papers about more efficient algorithms for adjustment set search. And the name, by the way, is really, there was a different tool in our group at the time, which was called Graphity. And because I was working, and that was for graphs, and I was working with DAG, so I just kind of took this name. The first version of the tool, I wrote this in 2009, and it was kind of finished in 2010. This is how it looks like today. And if you want to know, so it's a bit hard for me to track how many people exactly use this. The website, I can of course see how many people open the website every day. So that's in the 1,000 to 2,000 people per day on most days. But there's also an R package. I don't know if I can even track those downloads. I think that's not something that you can do. And you can also download DAGitty and use it offline on your own machine. So I don't know exactly how many people are using this, but I think it is a lot. Over the years, probably a couple of hundreds of thousands of people will have been exposed to DAGitty, for example, through teaching, because it's used in a lot of courses and a lot of universities. So that, if you have this kind of user community, and as you can see here, it has been also a slow process. So it started with maybe 5 users per day, and then it crept like slowly up. So what you can see is that there was one big jump in 2017, and that was actually the publication of the book of Why, which I think might have caused this, because that that really got a lot of people interested in causal inference. And then there was almost a second jump here, which I don't know exactly what caused that, but since then it has remained relatively flat on that level. Maybe 1,000, 1,500 people per day.
Can I ask a question, Johannes?
Yes, of course. Yeah, at any time, actually.
I'm curious, back in 2010, why did you decide to launch a website? My understanding is that researchers typically release code or they release an R package, right?
Yes, so
it seems unusual. So I was curious how you decided.
Because I think the community of people that I worked with, like specifically, were epidemiologists, and so these people would not know how to code. So for example, for them, the fact that this existing program, so there was one existing program in MS-DOS, and there was also an R package already out there, which is called DAG-R, which was also not very efficient, but it worked, right? But I could see that people, like the people that I interacted with, like my friends and so her colleagues and so on, they were really not people who would write code. So they needed some kind of GUI. And so as the field was really still trying to even, pick up these methods that were really very new, people would not really understand these methods necessarily. So I thought maybe first, before you can implement them in an R package, for example, and people would start to learn R, I wanted to have something that had a very low barrier of entry. And I also think that this is still something that is kind of powerful about DAGitty, is that you can just go on a website and just try it out. So there's no barrier in between. But I think it's also a very different community of users that use DAGitty than, for example, would use PyWhy, right? So my audience is not programmers. It's really epidemiologists who are trying to work with DAGs. And also lots of students, actually. And I think students are probably the largest groups of users that work, that just use it in a course where they learn about causal diagrams. And I think, so nowadays you might expect people who follow an epi program, for instance, to actually know R, but that was really not the case back in 2010. So back in 2010, people used SPSS and these kind of tools in order to do analyses, and you could really not expect people to know any code, R, much less Python. So I think that was, I really just wanted this to be as accessible as possible.
Thank you.
Yeah. So, and then, of course, sometime later, I also kind of regretted that choice because I thought, well, actually, if you want to do a real analysis, it would be much nicer to have this in R, right? So instead of having it as a website only. So then I thought, yes, having all of this in an R package would be nice because it opens up a different type of user community, like people who would do statistical analyses in R, and this community has been growing fast in the 2010s. So here it gets kind of messy because what the R package actually is actually it's using the same library that the web application also uses, and that's really for the sole reason that I'm unable to maintain two separate libraries in two separate languages, just time-wise, right? So I have a pretty mature implementation in JavaScript, and I just wanted to make it accessible. And so at some point there came this package V8 that allows you to run JavaScript code inside R. And so that really was what made this possible for me to release this R package with relatively little effort. So, and having it available, now the R package implements more functionality related to things that I care about, such as model testing, for example. Still, for example, and maybe that's something that we could talk about later, I think it would also be nice to have some shared, maybe C code base for the entire community that you could maybe wrap inside R or Python, and now with WASM, you could even put it into a website. That's also something that did not exist in 2010, but it's definitely possible now. Okay, so the code base is old and has been, there has been, of course, lots of bugs over the years. So there's reasonable unit test coverage. This is view of the unit test screen, which actually now I changed to run in the console. But here you can see that this code has a quite large testing coverage, which is also useful because I changed lots of things under the hood over the years. Okay, so DAGitty is both an website and an R package, and they both share a substantial amount of the code base. So I want to also go through how are now people using DAGitty and DAGs in general. So I think over the years, I think I have seen broadly 3 different types of use cases for DAGs. One would be that you use DAGs as a tool when you develop causal inference methods in general. So for example, you try to conceptualize something like selection bias, or try to conceptualize adjustment, and you wonder what is the best adjustment set, then you can use DAGs as a tool in that. And I think this kind of group of people who is doing this research is maybe the least interested in a tool like DAGitty or maybe even PyWhy. Then there are practical users. So people are really trying to use DAGs in empirical research. And I like to think about 2 different groups. Like, one would be the people who are trying to really make a DAG for the problem that they're working on, and that is a valid model of the problem that they have, and use that for causal inference. I call this positively practical because you're trying to positively use your causal diagram to generate some kind of estimate for causal effect of interest. What's also possible is that you use a DAG to conceptualize something that might be wrong with a given study, right? So there were quite many DAGs during COVID, for example, people trying to make the case that there was collider bias in certain studies that showed something. And that would be a way to use a DAG not to not to underpin an empirical study, but to show what's wrong with some other study. So it should not be very surprising that this negatively practical use is easier, right? So you can always come up with a model of something that's wrong with maybe a different study, whereas it's maybe way harder to actually draw a DAG that you can really defend and that you can really build your analysis on. So what I always envisioned with DAGitty is that the tool is really for the people who want to do this, who want to really build DAGs that generate that represent the data generating process that they need for their causal inference question. And that's brave. And to be honest, and to what extent that is already possible, that's a different question. And I also want to get into that later. Okay, so I just give you a very brief overview of what the R package does. So one thing is that we have a syntax that we can use to define graphical models. That was really something that I've spent lots of time thinking about. What kind of programming language or textual definition would you want to use for something like this? And I settled with GraphViz at the end. I mean, DAGitty's syntax is not exactly GraphViz, but it's really the intersection is fairly large. And that's because GraphViz natively supports mixed graphs, right? So you have quite simple syntax to have things like bidirected arrows, undirected arrows, directed arrows, and all of that in the same graph. And it also has lots of nice, like, for instance, you can make these scoped subgraphs that can really make it very concise. So if you have a human who wants to write a graph in a text file, then I think this is a nice language. Other alternatives might have been something like GraphML, for instance, like an XML-based language, and that would have been way more verbose and difficult to write. There is also a way to specify, and I found that quite important too. So there are different types of graphs in causal inference. So you have DAGs, but you also have, for instance, MAGs, PAGs, PDAGs, CPDAGs, you name it. And I found it quite important that you can denote what kind of graphical model you are looking at. So initially, I also really required people to always write, this is a DAG. But nowadays, I have implemented this shortcut that if you don't specify anything, then it's a DAG, because that's what most people use. And actually, by DAG, I really mean ADMG. So you can also have bidirected edges even in your DAG. Okay. So as you also seem to be doing, I really recommend people that that use the R package, that you first build your DAG that you're trying to that you build your DAG in a GUI, and then you just download it, or you copy paste the text syntax, and then you work with that further, because that kind of outsources the problem of really making a diagram into a software that's really just something like Microsoft Paint or something like so. You can just draw your diagram and then you're fine with that. And so there's different types of functions for querying the graphical structure, computing adjustment set, instrumental variables, and also some simulation methods, because again, back in the day when I started this work, there was no package available that you could really just simulate data from a graphical model, which is often very useful to do. Now that's different. So you have actually dedicated packages now for simulation, which are much more advanced than DAGitty. So these functions now, I mean, they're still useful. I still use them a lot, but there are better packages now that do the simulation if you need them, and they can actually also read DAGitty models. Okay. I'm just gonna, so you know these kind of functions, you also offer them in PyWhy. Okay, so this is a typical example of some paper that uses DAGitty. So what really almost all people do is that they build a causal diagram, and then they compute an adjustment set. And so if you see these things in papers for the first time, then you really start wondering, is it like, is this real? Like, so this looks like a very complicated model. And to their credit, so the authors here, they invested a lot of time in trying to find literature references. So what you see in these numbers are these are annotations with literature references that underpin, for example, the fact that there's a causal effect of gender on physical activity, for instance, which is very laudable. So I think they probably spent quite lots of time building this diagram. But the issue here is, for example, that it's not so much the present edges in the causal diagram that really that encode the strong assumptions that you're making, but it's more the edges that you are lacking, right? So for instance, there is no arrow going from, for instance, gender to smoking. And that's something that actually is a bit questionable because there are gender disparities when it comes to smoking behavior. And it's something that I saw lots of people maybe misunderstand about graphical models in general. It's like how they work. Like it's not like when you draw the arrow that you're making a very strong assumption. You're just saying there might be a causal effect. It could be very weak, even maybe unmeasurably weak. And really the strong assumptions that you're making are in the absent arrows. And so after a while, I really started thinking about this, like, do people actually get causal diagrams and how are they using them? And this is also not entirely by accident. Oh, sorry, this actually, I'm going to skip this here. Yeah, let's just actually skip that because I want to move to this part where I suddenly found myself in a weird situation that I was kind of in the middle of this very heated debate where people were talking about this issue, like, are DAGs actually helping? Are they helping to science, right? So are they helping to draw better causal inferences and have a better founded empirical research in observational settings? So in this article here by George Davey Smith and Nancy Krieger, they argue that DAGs are maybe overused in epidemiology and that they should not have like a privileged position, and that there would be other methodologies that kind of should also be used alongside DAGs. If you have like any interest in this, I really recommend reading this whole article and also the replies, because there were really a lot of replies to this article by various people, including Julia Pearl, going into this argument, and then another reply on that reply. And so I thought these discussions were really very interesting. But so yeah, one of the points that they're making is exactly that, that they're kind of saying, if you have these super complicated diagrams, how certain can we actually be that, or how much faith can we have in these kind of very complex models? Like how much credibility can we really lend these things that seem to be so complex, and what kind of assumptions are we even able to understand the assumptions that we are making, and is this really improving our inference? So for me, maybe more relevant was that they also were very critical about DAGitty, or like they were careful maybe not to attack it directly, but it's kind of an indirect criticism here that they're saying, okay, if you look at how people are using the program, so for instance, George Davey Smith looked at papers, and he told me personally that he really had looked at all of these 200 papers, and he was kind of shocked to see what people did there. So they would basically just say, well, we use the software and then we find the adjustment set and that's it, right? So in many cases, they wouldn't even show the graphical model. They would just say they use DAGitty. And so George, and he had a point here, he said, well, this is not, I mean, just having a software that you use is not making the research better, right? It all hinges on the model itself. And if you're not even showing that model, then there's no way for me to really see whether I believe your model and whether I believe then the inference that you are building on your model. And so I think he had a good point here, and actually I will show later that I really also kind of agree with that part. There was also some less reasonable criticism where he was saying, well, and also DAGitty automates everything, including mediation analysis and selecting instrumental values from data, which is not true, right? So, I mean, this is not something that DAGitty does. So DAGitty only starts from a given graph and then does kind of deseparation algebra. For instance, you can give it a model and then it says, well, according to this model, this would be an instrumental variable. So as you can also see from the fact that he's giving an incorrect definition here of what an instrumental variable is, I think that's partly just because these people don't fully understand causal diagrams, or at least they didn't at that point. But this was really, so this part was really unfair and false. I mean, I talked to him later about it, and we kind of found disagreement. But so for me, that was a quite interesting experience, being suddenly targeted with this kind of criticism, because it had never been my intention, of course, to encourage people to do bad science, for instance. So I agree indeed that if you would do this and you would rely on entirely automation of analyses, then I wouldn't believe this to improve the practice of causal inference. But for me, DAGs had always been about the opposite, really about forcing you to think more and not less, right? So I'd always been, for instance, quite skeptical of structure learning, because this is an automation of analysis in that kind. And that, yes, to me, runs the risk of really letting people do things that they don't fully understand. But with DAGitty, I was always kind of conscious that I really want people to understand what they're doing. And that's also why this visual display is so important to me. And I've seen, for instance, in PyWhy, you also have these. You are listing the assumption, like if you run these inference methods, and then you list the assumptions that you're making, right? So, and that's, I think, is really great, because that's exactly what you want. You don't want to hide these things under the hood, but you really want to make people aware of the assumptions that they are making. But here it looks like maybe I was a bit too successful and made it too easy for some people. So that kind of continues. For example, I have been quite interested in the model testing question. Yes, sorry. Yeah, please.
Johannes, I just have a comment on that. It's interesting. So you made it very easy, such that people were maybe misusing it, right? Did you consider having a documentation or having some kind of step-by-step guidelines for users? It could just be a PDF document, for example, right? On how to use DAGitty.
Yeah, I've been, I mean, there's a manual that's very limited. We have been, so to be honest, I don't know if the field is ready to provide the step-by-step instructions, right? So we have one tutorial actually that I've written with Anku on. So one thing that shocked me in the case of testing, for example, is that nobody seemed to do any model testing. So people would just make a model and they would use it, and there was no testing done, even though DAGs have testable implications. So,
right.
But then I also looked, and I didn't see any software, at least back in the day, that really supported this. So I went into this, and I wanted to really make people aware that you can test models, because if you do, most people will find out quickly that their models are quite wrong, right? So I've never seen anyone come up with a correct DAG from scratch. And whenever you really test it on a data set, you see quite large discrepancies there. But now the really puzzling thing is that they even attacked me on that as well. Like, so there is this special issue that also the DAGitty paper itself was published in. And so they say, well, these packages are really nice and really useful, but they lead you into the temptation to do testing in order so that you can modify your model later, and that is really concerning, right? So they sell it as a negative thing, that you can do testing, because that would allow you to modify your model and make it better post hoc. I agree with that, because those are exactly my words from the same issue. Where I say, well, testing is good, right? So it's good to be aware if your model is wrong, but what you should not do is that you keep just tweaking your model until it fits perfectly post hoc, because that is overfitting indeed. But this view that you should not test your models at all, because otherwise you might be doing overfitting, is still very pervasive in epidemiology. So very few people still to this day test their models. This is something that I still find very puzzling to understand. So that has been something that I found very unexpected in a way, right? So that users would use your software in a way that you had not foreseen, and also would completely disagree with some kind of advice that you were trying to offer. So given all this, we joined forces with a larger group, and this was really led mainly by Peter Tennant, Mark Gilthorpe, and George Ellison. And we said, well, let's actually go do this. Like, let's really review the literature and try to find all the DAGs that have been published so far, at least in our area that we understand in health research. And this was really interesting. So we tried, so that was in 2020, so we tried to find all of the papers that had ever published any DAG. Back in the day, there were like 200 citations, 300 maybe to DAGitty, and we traced all of them, and they also tried other things like literature search to find papers that proposed DAGs. Now, if you would repeat it, it would be, I think, more than 3,000 already. So that's really changed a lot even in these years. But so in this paper, we included 234 DAGs in the end. And so the first interesting thing is that there's, as I said before, there's lots of people who use the DAG, but they don't show it, right? So 144, at least the majority, but still not all of the papers, they show the DAG. Then you have also the interesting gap here where they say we computed an adjustment set, but they don't tell you what the adjustment set is. So even, and I think that is really in less than half of the papers, they would even say what they adjust for, which is, yeah, I think that's something that really should not be the case. So at least they should mention which variables they pulled out as an adjustment set. But of course, they should also just show the causal diagram. Even fewer people define what target estimate they're interested in. So maybe that's because sometimes they find it obvious out of context that they want to have a total effect, for example, rather than a direct effect. Okay, and then some more interesting things. For instance, we looked for the presence of unobserved variables, because you could argue if you don't have any unobserved variables, then maybe you don't need a full DAG for reasons I will explain later. Or maybe it's also the case that you just build your DAG from the variables that were in your data set, which, yeah, is very convenient, but very likely there will be other things that are also important that you did not measure. And so 25 of these papers contained what we can call clusters of nodes, right? So so-called super nodes, where, yeah, technically speaking, if you use a node like that, it's actually not a DAG anymore because you can't just cluster nodes together like that. So here we have an example that actually does contain unobserved variables, and yeah, however, mostly on mediating pathways and no unobserved hidden confounders. Here we have an example of what is meant by supernode. So a supernode is here, for instance, like a demography. So we have one node in a DAG, but actually that node includes 3 different variables. We have socioeconomic status, which includes 2 different variables, and then we have C over here, lifestyle, which includes actually no less than 5 different variables. So actually, interestingly, people have now started to work out a theory to what extent can you actually do that. Like, so let's say you had a DAG and now you're just clustering 5 nodes together. What would you even still be able to infer? And that's actually very much less obvious than one might anticipate. But it's something that people don't seem to realize that when they're using a DAG, that you can't just cluster nodes together. Here we have another instance of what I mentioned earlier, where people really try to give a reference for every single edge. I think here they actually do have one for every single edge, but not for the edges that are missing. So that's something that we also stressed in the review, that these missing edges should be given more consideration. We have also found some instances where people use, for instance, a DAG, and then they derive an adjustment set. But then the adjustment set doesn't contain, for instance, this variable, right? So they say, well, the adjustment set doesn't contain it, but we really want to have this in the model and also sex. So we just put it in there anyway. And at what point you can wonder why then use a DAG and not just your favorite list of covariates, right? So I don't know if that is theoretically justified, for example, to take an existing adjustment set and just put an extra variable in there. Then there also are still mixtures of, It's also very funny how they mention now they reference the software, like they say, okay, DAGitty version so and so Utrecht, which was I think the place when I lived there back then. And so here they would also only call something a confounder if it really changes the estimate of the exposure. So otherwise, yeah, so they're kind of doing some hybrid between a structural analysis and a data-driven analysis, which also, again, you might wonder to what extent that really makes sense. So, and so now more.
Johannes,
Yes, please. Yeah.
All these papers are peer-reviewed and they passed the peer review?
Yes, all of them are peer-reviewed and published. So you can
Isn't the problem broader? Like it's probably not DAGitty's problem. The reviewers don't catch these mistakes, meaning they don't understand some of this.
Yeah, it's a learning process for sure, right? So I mean, DAGs are relatively new still. I mean, not new actually. I mean, as I said, this paper by Green and Pearl and Robins that dates back to 1999, but still people are figuring out how to really use them. And some of these things are changing. So, for instance, more recently, you will find that people really do publish their DAGs more than they did in the past. For partly because of this review, which was published, and we really said, well, based on what we observed, we would recommend, for example, so we ended with a list of concrete recommendations that people should follow if they use DAGs. Right? For instance, show the model or mention your adjustment set or something like that.
Have you considered having a shareable link? So let's say I'm a researcher, I create a DAG.
Mm-hmm.
Can I just have a permanent link created for that,
Yeah.
and I can
You
share that in my paper?
You can actually do that now. That has been possible in DAGitty for, I think, already for 6, 7, 8 years.
Oh, wow. Okay.
And so there's a database now that now contains 17,000 causal diagrams that have been saved. And so these have all like permanent links. And I'm also now working to make these really DOIs so that you don't only have like a link on the website, but really a proper DOI. And that should be, I think I will have that up and running in a couple of weeks. But it's not, I mean, it's not used that much, but also because you can just put your DAG as an, as a appendix to your paper, for instance. You could just have a supplementary information. And but yeah, I thought, for instance, that was something that I thought people would do this more, that they would share DAGs with each other and maybe improve each other's models. But a lot of times people seem to be doing one-off modeling, right? So somebody has a data set, they make a DAG, and then that's that, and it doesn't get picked up by someone else. So, but yeah, that's definitely something I have been actually already implementing. So, in all the cases, and we didn't find any paper that used the DAG for anything else than to determine an adjustment set, right? I mean, in theory, you could also do other things like to do calculus or an IV. But this doesn't really happen in practice. In practice, it's still all covariate adjustment. And now the interesting thing is that if you want to do adjustment, then you don't always necessarily need a full DAG, right? So you could use something more simple like this disjunctive cause criterion, where really you just have to go through your list of covariates and you need to know if each covariate is a cause of the exposure or the outcome. And if it is, then you include it in your adjustment set. And that works whenever there is any adjustment set, then the set generated by this method is also going to be an adjustment set. And so we looked into the published DAGs and also in the entire DAGitty database, actually, if we could find any DAG where this DCC would not work, and we couldn't, right? So there were thousands of models. And for each of them, you could also find an adjustment set just by using the DCC, which arguably is much, much simpler to do than drawing this full DAG where you need all of the relationships between all of the covariates. So that's something else that I learned from this, where I think like maybe in a lot of cases, people don't really need to DAG. If all you want to do is adjustment, then maybe this is a bit of a simpler alternative. Okay, so yeah, so this is just all I wanted to share, really. So it has been an interesting experience in this past few years to really see how people are using DAGitty, what they're doing with it, what they're doing with DAGs more generally speaking. Yeah, so a few things that I learned from that was, for instance, that there's a lot of lack of testing, which is really something that I've then started to work on a bit more. But yeah, they're still quite concerned about doing this. So yeah, thanks for your attention, and I think I'd like to just also have a bit of time for discussion if possible. And so I'll stop here. Thank you.
Thank you so much, Johannes. I think we'll open for questions. I think if you have a question, just unmute and you can speak.
Yeah, I wanted to ask Johannes that you mentioned that people mostly use DAGitty for adjustment sets. So do you think there's a lack of knowledge about other estimation methods, or is it like they don't need anything else? Or
Yeah, I guess it's like it might have to do with the fact that it's very health/epidemiology focused. So from what I understand, and maybe you know this better than I do, is that, for instance, in econometrics, adjustment is not that common. Like people would rather go for an IV, for example, whereas IVs are much less used in epidemiology, and people are more used to kind of adjustment type methods like the G formula, for example, which is essentially an adjustment method. So I don't know if there's really good reasons for that, or if that's more of a cultural thing. I believe people have thought about this, but I don't really know. So it could be that if you do the same study in econ, maybe with people who are using DAGs in econ, then maybe they would be doing other things.
Yeah, just to add, I think that's what.
Yeah, sorry.
No, I was saying just to add that we see the same pattern in PyWhy as well. So DoWhy, for example, does support other identification methods, but backdoor is by far the most common one. Yeah.
Yeah, I guess, I mean, if you're talking about do calculus, for example, then also there's no, the statistical side of that is very much not well understood, right? So with adjustment, you're tying it to regression methods, which is what people use and what people understand. If you're doing an IV, then okay, you have two stages, least squares or something like that. I think that's still understandable. But for instance, front door even, I think there's a bit more theory now on front door, but if you just run, for instance, the do calculus and you get any formula, then you have no idea you can do a plug-in estimation of that formula, but you really don't know how well this is going to work and how you can get confidence intervals. And so these things, I guess, might still be an impediment.
Yeah. One question I want to ask is there a way to integrate DAGitty more closely with the Python ecosystem? So just like you said in R, you found a V8 library that made it possible to create an R package. So the reason I'm asking this question is I think for a long time in PyWhy, we have been thinking of a GUI to support new users. And rather than reinventing the wheel, we are thinking whether DAGitty, there could be kind of a tight integration so that people can just use that within the Python ecosystem.
Yeah, I mean, how would you envision that? So calling out to a website from inside Python or something like that, or how would that work? I know, for instance,
exactly. Like Jupyter notebooks work, right?
There's a guy who made an add-on for DAGitty to work inside of Jupyter. So you can, I haven't looked at this myself, but there's kind of a third party. I link to this on the DAGitty website. So he has made some, I don't know much about Jupyter, but basically it's made it possible to use DAGitty models in Jupyter. So is that something? Is that
yeah? That would be useful.
So
I think we'll take a look at that. Yeah, something like that would be very nice because PyWhy, all of our libraries work in Jupyter very easily, and so people could also call DAGitty within that. We can check that.
I can show you the link. It's yeah. So actually, you can just do that. I just posted here. This is the this is the thing I was talking about. So it's Jupyter DAGitty extension. So you can have like a DAGitty thing in there, and it's interactive, I think. And so yeah, that's already been done, because basically that you can I wrote DAGitty to be embeddable, so you can embed it in any HTML website. So that includes Jupyter. I think it probably wasn't really too hard to get this done.
Got it. Okay. Leonardo, go ahead.
We can't hear you. You're muted.
Are you hearing me now?
Yes.
Okay. Thank you, Johannes. It's a pleasure to meet you. To me, you have opened a lot of opportunities in terms of doing science and research. I'm based here in Zurich, and I'm a postdoc in ecology. And I have discovered the DAG and the causal inference this year. So I have passed the whole my PhD without this fantastic tool. But what I'm going to ask you is about to further discuss about the testing the consistencies of the DAG, because we as ecologists, for example, we collect data, but we have a lot of missing data. When I'm confronting with my DAG, sometimes I'm not trusting my data at all. I'm trusting more the DAG. Then how can I test the consistency of the DAG? Some discussion also about the other part is that I'm seeing now is something like doing some Bayesian network inference in terms, let the algorithm establish the structure of the DAG without further thinking ourselves about the causal links in between the covariates, the outcome, and the exposure.
Yeah, so I guess the second part, what you're talking about, is essentially what structure learning is all about, right? So that's when you have algorithms that can discover structures. There are always some limitations, because there's always different equivalent causal structures that explain the same data equally well. So you will still have to then decide between those. But that's really a large field, and that's quite a lot of things have been done. So, for instance, if you want to look at the package BNLearn, you will, I mean, that's a package that focuses more on structural learning, or PCAlg, or probably even PyWhy. And also, by the way, Anku's package PGMPy implements some structural learning algorithms. So the first part is, it's interesting, because you're right. I mean, inconsistency just means that the data and the DAG, they don't agree, right? So it could be that it may well be that there's something wrong with the data. And I've seen that myself when sometimes I let students I mean, I have this course in causal inference, and I just always let them build a DAG and test it. And so we found countless data sets on Kaggle, for example, where there was some issue. For instance, people build a DAG and they realize, oh, the data fits the DAG too well. It's just perfectly fitting. And so then you dig down and you realize this data is actually simulated, for example. So that is not real data, it's simulated data. Or there are some weird relationships between variables that should really not be there. But I think that's equally useful, right? So if you, I mean, at least you see that there's some issue, that's something with the data that you didn't expect. And it doesn't have to mean that your DAG is wrong. It can indeed also mean that the data is wrong, and in which case you would have to figure out if this issue is also affecting your conclusions from your analysis. Maybe you can deal with it somehow. Often it's really hard to even understand where it's coming from. But I think this is quite useful, actually, because it really shows you that you're making assumptions that do not hold, and that might be an issue in the data collection itself, which is also important to know about.
Do you suggest in following the testing the consistency to always make more than one DAG and present more than one DAG within a paper, for example, because I'm reading paper and there's only one DAG most of the time.
Yeah, I mean, that's something that also has been frequently suggested. Often it will not really matter if you change your DAG, then another DAG might still work. It might still give you the same adjustment set, for example, right? So you don't really depend on every single arrow in the DAG being correct. For instance, you can already now derive adjustment sets from entire so-called Markov equivalence classes, which can contain a lot of different DAGs, and you just have some inference strategy that would be valid for all of them. So that's also something I would indeed encourage people to do if they don't feel certain about some directions of arrows, for example. They might just try both and see if it really makes a difference. Yeah, but you're right. I mean, it seems simple, but it's not. I don't see much evidence of people actually doing this out in the wild. So there's clearly still some kind of translational gap.
Thank you.
Are there any other questions? Okay, if not, we'll just thank Johannes again. Thank you so much, Johannes, for taking the time and talking to us. I think it's kind of a labor of love to maintain a package for over 14 years. I think we all appreciate that, and it's also unfortunate that you've been at the receiving end of criticism. But I think
it also
if anything, I think
yeah,
you've perhaps done a lot to raise awareness about DAGs in epidemiology and also many other allied fields. So I think the criticism itself is a mark of your impact.
It's also I just picked this because it's interesting. You also get nice feedback from people who really thank you for, I mean, that's also what is nice about this. The overwhelming feedback has been positive, right? So I don't wanna give a false impression here. I don't know how it is for you guys, like how you get feedback from your users, and because I guess your community is probably more active on GitHub directly, so you probably get more things back. I also saw that you had quite a long list of contributors, people who contribute code back and so on.
Yes, yeah. I think we often hear about new domains or new applications that people are trying out PyWhy tools for. And one thing that has helped us is we also have a Discord community. So it's like a publicly open community of people. Many of them are contributors, but many people also come there just to learn how to use the package and share some problems they have. So
yeah,
I think in that way that has been useful to see that people are finding that community useful.
Yeah, I guess, but I think you're targeting developers, right? So you're targeting people who know how to install something in Python, for example, which I think most of my users don't. So I think it's really very different. If I could try to open a Discord, for instance, it might be interesting because I'm using Discord for teaching all the time, so I'm on Discord constantly. I would guess that my users normally wouldn't typically be the kind of people who join a Discord channel, for instance, which is something that, yeah, but maybe I'm wrong. I mean, it might be interesting just to try it. Yeah, so if you want to keep in touch, I'd be very interested in that, and maybe see if we can have some I don't know, mutual beneficial interactions of some kind.
Yeah, I think this Jupyter extension seems very promising. So I think within our community, we'll explore this idea, and we'll actually try to see if it's feasible on our end in Python. And if something works out, then yeah, maybe we'll send you an email and find a way to collaborate. I think the ideal case for us would be that people can just, use Jupyter notebooks, create the graph inside the notebook, and then directly consume it into our tools as well. So
yeah,
we
it
try
should
to
not.
keep
It should,
it out.
it should not be too hard, to be honest. I mean, there would have to be some more, you know, a simpler version of the of the interface. So for instance, now you can really embed DAGitty in the Jupyter Notebook. You can use all of the key bindings, for instance, to make new variables and all that stuff, but probably you want to provide some more like basic interface where people can also click and things.
Yeah.
But it really shouldn't be too hard to do. Yeah. So yeah, let me know what you find. I would be really interested in that. So thanks, and have a good night, I suppose. It's quite late in India now, not?
Yeah, it's late in India. It's morning in the US for some people. Yeah.
Okay.
Have a good evening. Thank you so
Have a
much.
good night. Bye.